Do you know how your paddle is made? Or why it's made that way? I'm guessing you do, because that's why you clicked on this video. But I'm drinking a lovely American single malt. I got Mirador here from Balcones. And there were dozens of decisions that were made in making this whiskey, right? What grains to use? How long should I ferment it? What should I age it in barrels? Which barrels? How long should we age it in barrels, right? So there's dozens and dozens of decisions that have been made in making your pickleball paddle too, like my bread and butter loco here. Now, I'm pretty good at whiskey. I know how this liquid's made, but I'm just a noob at paddle construction. So, you know, being the interested fellow that I am, I wanted to dig into that, and I bet you did too. So I called up your and my favorite pickleball nerd, Justin Barton from Pickleball, etc. And we're going to ask him some questions, and we're going to learn this stuff. So welcome, Justin.
Hey, thanks for having me.
You bet.
That was quite the intro.
How have you been, man?
Good. Just got back pretty recently from 2 weeks in China. Really at the factories, actually, you know, seeing how the sausage was made, as
Excellent.
We're talking about today. So working on the paddles. So it was good.
Perfect. What was one takeaway from the factories that maybe you didn't realize after visiting them there firsthand?
You know what? This is going to sound crazy, but my expectations were actually pretty on point. I actually expected to go there and see some stuff that I was like, whoa, this is how they do that. This is how they do that. But, you know, from seeing the videos and talking to people online and kind of doing my own research, the most surprising part was how little I was surprised, which is probably a good thing, you know. I know how the process works, yeah. But yeah, I mean, we toured multiple factories, and there are slight differences factory to factory, but overall, it's I guess I don't want to say fairly straightforward, but once you understand the basics, it's pretty straightforward. You know, composite building.
Sure. Well, no, that's good, actually. I think that's going to be reassuring to a lot of us that how we think it's going to work is basically how it works. So walk us, as the noobs here, walk us through really soup to nuts. How do you make a paddle? Like, how does all this process go? Just, you know, quick fire, but...
Yeah. So, and before I dive too deep, I just want to tell your listeners that you were very prepared, very professional. You guys should have seen. Martin sent me over a page of notes, and I said, get that out of here. We're not prepping anything. We're going to do this conversation style. So we'll see if the wheels fall off, but this is going to be no prep. We'll see if I can throw you off your notes or not, or if you bring us back in.
Perfect.
But yeah, so to answer your question, I mean, of course, like every product, it's not too different than product design across, you know, other industries. Every product's got to start with like ideation, right? Like, what are you trying to make? Why are you trying to make it? Like, what niche are you trying to fill within your brand and the market? So when it comes to paddles, it's like, it may be as simple as, oh, we haven't released anything in, you know, 3 months, and we need something on the timeline because this market moves fast and brands need to keep releasing. So that may be the genesis of the paddle. It may be that you have a really interesting R&D idea, and you're like, "Ooh, I'm going to make something brand new," you know, that no one's ever done. And then that's where it starts. And how you start kind of dictates how it goes, because those are very different starting places.
Sure.
If you're just trying to make something decent, you know, add a product to the lineup, it's not going to be too hard. You're going to get in contact with your manufacturer, the factory. You're going to say, "Hey, what do you guys got going on?" You're going to take a look. You're going to sample all the different things that they have going. You're going to find a sample that you like, make a few tweaks here and there, which we'll kind of get into the, you know, nitty gritty of the details. And then after maybe a couple tweaks, you'd be like, "We like this one," you know, and then comes the business side of it. You got to do all the marketing, all the launch, all the design, all the internal stuff, figure out how much you're going to order, plan it all out, order from the manufacturer, slam it all together, sell it to the public. But if you go for a more unique route, like I mentioned, if you're trying to do something new, basically just extend that R&D and sampling process by 6 to 9 months. And then the end process is similar. And you also have to be okay with failing, spending money and time and resources on something that may never work, because not every idea is, you know, perfect, especially when you're trying something brand new.
Yeah. So you're saying you can kind of go, you said 2 different ways. So if you're a paddle, you want to release a paddle, you can do a lot of the fancy R&D on your end bring it to a company and say, hey, can you implement this? Is this practical? Or you can come up to the company and say, look, I got this design. I want to build a foam power paddle. What have you got? How can we work with this?
Yeah. And I was answering that question from a brand's perspective, like, you know, a company, if they want to make a new paddle. Were you asking more specifically like me, Pickleball, et cetera, as a consultant to these brands?
No,
What do I do?
as a company.
Okay.
As a company, yeah.
Oh, okay,
yeah.
cool. Yeah. So, and just to, I guess, say that at the beginning of this interview for anyone who doesn't know me or what I do, I am a product development and business development consultant for pickleball brands. That's a fancy way of saying I help pickleball brands design products, mainly paddles. And when I say design, I don't mean graphic design, although I may have some small input there. It's more like the engineering, the materials, you know, things like that, actually building the paddle structurally and working with the manufacturers to make that happen. So that's me, I guess.
Perfect. All right, so we're building a foam paddle. Let's say we're building this loco that I was talking about here, right? So step one, you get your core. This is an EPP core, right? So you've got your core and it's cut out in your elongated shape, okay? And so then now you're gonna wrap that with EVA foam. So is this, this sheet of EPP, is it then cut with a machine to that specific shape? And then that EVA foam, is it cut as a strip in that shape, or is it just a long strip that you then kind of fold around that foam core?
All of the above.
Okay.
So
okay.
the central, more high density foams like EPP, they can be made in multiple ways. You can mold them directly. It's a more expensive process, but it's more consistent. And if you're doing large orders, it's oftentimes, I don't say better. Let's just say that. So let's picture that local EPP core. It's like a, you know, roughly an oval in the center there. You could pay for a foam mold where they mold them and then out comes the mold, the perfect core already in its shape. Boom, you got your piece. That's one way of doing it. The other way of doing it is using a machine like a laser cutter. And then instead you have a large sheet of EPP, put it on the laser cutter. The laser cutter is going to go in and cut a bunch of, you know, core shapes out of the one sheet of EPP. So obviously there's more waste that way because now you have everything in the sheet that couldn't be cut into the core shape. But oftentimes it's more economical for smaller orders, or definitely for prototyping or early on, because the molds themselves for the foam cost a lot. For EVA and more lower density foams, you can do exactly what you said, where it's a sheet, they cut it into strips, and they're just gonna like kind of run that strip around and then let it meet. Or they can do die cutting, which is essentially like a giant cookie cutter. They put the sheet in the die cutting machine. They have dies, which are like cookie cutters. They put it on top of it. It presses it down. It cuts it, not like a long strip, but already in the exact shape that it needs to be.
Gotcha.
So different types of foam, whether they're, you know, blown foams or beaded foams or different types, they, you know, use different methods to get them to their final shape. But for those two specifically, and most of the ones we see as main core and outside core, it's going to be those methods.
Okay. So now we've got those two, and they're in their mold. Now we apply the face sheets on there, okay? And those face sheets are often mostly 2 or 3 layers, right? Or sometimes 4 now. Are those layers then just placed directly onto that foam with an adhesive? You know, we can talk a little bit about that. And then they're either heat pressed or just glued, right? You know, they call it cold pressed or thermoformed or heat pressed. And then wrap an Edgeguard around as long as we're not edgeless. Is that basically how you build a paddle?
Yes. So the face sheets, they call it like a layup because when you're initially making it, it's carbon fiber or fiberglass, and it's like a cloth.
Right.
It's like basically like a wet cloth, a very sticky wet cloth, and they will lay them up multiple layers. And like you said, most are 3 layers. There's actually a significant portion of 4-layer layups. There always have been. There are very few 2-layer layups, one in particular. But yeah, so they will make the layups usually separate as a early step, you know, because when they're going to lay these carbon fiber cloths down in different orientations, right, like this, and then they cross the fibers because it's long fibers, and then they'll cross them again. That adds strength, it adds rigidity, and then they're going to make them wet, and then they actually kind of thermoform, for the term those, because they are soaked in epoxy. Basically, there's resin impregnated in these, and it's only activated with heat and pressure.
Right.
So they make these layups, they put them in a press, and then they cook them. And then when they come out, it's a hard, sheet. Like it's a hard carbon fiber sheet like you'd picture on the front of your paddle. Now, next step, like you said, we have our foam cores. Now it's like the final assembly, and there's a couple ways you touched on. Cold pressing, even though a lot of times there's heat involved in that, or what we call thermoforming, which is like hot molding. In cold pressing, it's more simpler. It's basically what we just talked about with the layup, but you just had the foam in. So they'll have a mold still just to hold everything straight. They'll lay down a face layer, adhesive, the core, adhesive, the second face layer, and then they're going to put that in to a machine that presses it and heats it. The heat is usually to cure the adhesive. And then, like you said, come out from there, it's put on the handle pieces, put on the edge guard, you're good. For thermoformed, which is most paddles we see these days, there's a whole extra set of pieces. The entire edge of the paddle, it actually has carbon fiber reinforcement, and most of them also have an expanding edge foam. The purpose of the expanding edge foam isn't pickleball specific. It's so funny because all these companies like to market their edge foam as something special, and like when Thermoforming came out, everyone's like,
stabilizing edge foam, right?
Yeah, all these different marketing things, but in reality, in composite molding and other types of molding, there have always been some type of structure in there to make sure the mold gets filled out, right? Because you want the corners of your paddle or bike frame or whatever it is to be pushed out to the edge so they fill the shape completely.
Right.
And you may have, sometimes they have bladders in there that they fill with air actually to pressurize and push everything out. But easier is they just lay in this edge foam, which is actually really small before it expands. It's like a tape. You just tape it around there and they bake it, and as it heats, it expands, and that pushes all the corners out, make sure the paddle has nice sharp edges and everything is the shape as it should be. A side benefit is with these foam cores and stuff, it also holds the foam core in the middle, very nicely. It seats everything in. And yeah, with that edge foam, you also usually get an extra layer of carbon fiber around the edge of these paddles. That's why when Gen 2 came around, all of a sudden the sweet spots were a lot better. There was a lot more power.
Right.
You're pretty much making one full closed unit of a paddle that's fully carbon fiber, fully composite, and it just has a lot more strength, a lot less beam flex, more rigidity. There's more, tension on the faces. I say that lightly because it's not exact, but that helped the paddle's performance, and that's stuck around even through what we call Gen 4 now, full foam paddles. Most of them are thermoformed in this manner.
I was going to ask that question. So in our traditional polypropylene paddles, that was a big jump from Gen 1 to Gen 2, and then Gen 3.
That was the biggest jump.
Yeah. And so when we foam, some are thermoformed and some aren't. Does it cause as big as a difference in the thermoforming the foam paddles as it did for our polypropylene paddles?
Yes. Yeah, absolutely. Because it's still achieving the same material qualities, right? Like it's, as a unit, the paddle as a unit is much stiffer when it comes to beam flex. Like imagine it flexing this way,
Right.
if this is the part that hits the ball. Makes a big difference. Also, you're adding significant structure, rigidity, and weight around the perimeter, which we all know adds stability.
Right.
So when you have extra stability, you have better twist weight, you have better off-center hits, so it's a larger sweet spot. So yeah, all the same things we learned from Gen 1 to Gen 2 will also apply to foam paddles that are not or are thermoformed. Now, thermoformed, I'm using this term in the pickleball sense, although it's not exactly how it's used in manufacturing, but we'll just keep using it in this case.
Sure.
And I won't even name any names, but for those of you who are deep in paddle nerddom, if you've played full foam paddles that are not thermoformed and you played the ones that are, but it's a very similar build, you can tell the difference. And it's the same difference we had from Gen 1 honeycomb to Gen 2 honeycomb.
Sure.
So yeah, it does the same thing. It's still really valuable, for all those reasons.
Sure. So, we've kind of focused on foam because obviously that's dominating the market.
Yeah.
Is polypropylene dead? Are we going to see polypropylene paddles continue to be developed in the future?
Yes. You will, of course, just because of the economics of it, and because there's a lot of consumer education that needs to happen to teach people about foam. Not only that, these are the earliest iterations of foam. We've only had foam paddles on the market for like a year,
Yeah.
Well, mainstream
Sure.
mainstream foam paddles. And then we've had a really big influx in the last six months, we'll say. So now they've gotten really good, but we're still in the infancy of foam paddles. And there's a lot of different ways to use foam, tune foam in ways that you couldn't do with honeycomb. So while foam is still in this kind of infant stages where we're still figuring things out and may run into issues or lower potential performance, honeycomb's still going to hang around because it's a safer bet for a lot of these companies. It's also right now cheaper to produce. So, and like I said, you don't run into the consumer education thing. If you already have a good thing going and let's say you're a big brand that sells the most paddles and you have a ton of sponsored pros and they use honeycomb paddles, your next one might just be honeycomb again because people are going to buy it. And if it's just marginally better, that's good enough.
That's right. Ben Johns is playing with it. It must be the best.
You picked it up. You picked up what I was putting down there.
Excellent. All right. So back to foam, because I think that's most of our pickleball nerds that watching this is going to want to learn all about the foam paddles, because that is the new ones. So the very first foam paddle that came out, the mainstream one, was what, the 008, if you can call that mainstream, just big old one sheet of foam, right? And then the one that probably picked up the most as a good performance paddle was the True Foam Genesis, right? And that's when we learned about their, I think they called them voids, but the holes in the foam. And so over time, we've seen a few that have holes in the foam or divots in the foam. Now we're seeing some cuts into the foam. How does that change the performance of a foam paddle by putting cuts and holes and divots and all that kind of stuff?
Yeah. Big shout out to Carbon, because if they hadn't come along with a good performance foam paddle, it might have been a failure to launch thing.
Absolutely.
Right? Because other companies had tried it, and it was even in the past years. So anyway, I know you said it, but I tend to think of the True Foam Genesis as like the first good foam paddle, the one that actually started the movement and made people convinced, hey, this can actually work well. Because all the ones before were kind of crap, honestly. But anyway, that's neither here nor there. To answer your question, voids, cuts, divots, whatever it is, two main things here. Number one is just practical engineering. Sometimes you have to manage weight. And when you think about a pickleball paddle, the market is actually really picky. They want something between 7.8 ounces and 8.1 ounces stock. And if you make it outside of those ranges, it's going to hurt your sales. Right. So you are looking at a 10-gram window, which when you consider the amount of materials and the different things and the variables in building a paddle, that's actually a really tight window. And that's a big challenge in R&D and engineering. Well, one of the main things you can do, and Carbon figured this out, and it was really smart of them, is, hey, you just remove material in places where it maybe makes sense for performance, which I'll get to in a second, to get it to the right weight. So that's key. Now, the performance enhancing aspect of it is just adding flex or deflection, is what we'll test the paddles at. Pocketing, dwell time are these words that you will hear people talking about the playability of a paddle. With the types of foams that we're using right now, EPP specifically, when you just use a solid slab of it, it's pretty dead. I mean, it's got a lot of the right material aspects, but man, it's really not giving you much unless you engineer something into it to have flex and more rebound and things like that. So all these different things are attempts to engineer flex and energy return into the foam. And real quick, I'll just say about EPP and why we have to kind of go down this route. EPP right now is basically our best option. There are a ton of foams, and I'm looking right now at like maybe 80 prototypes just in boxes in my closet right here. And they have various types of foam. And the thing is, they all, or most of them, don't work. Because there is a very specific set of boxes that you need to check in order to be a viable material. And at home, you might just be thinking about playability, but there's multiple boxes that have to do with playability and feel and vibration dampening. And then there's multiple boxes that have to do with, will it pass testing? Does it return too much energy? Does it deflect too much? And then there's multiple boxes that have to do with durability. Does it have compression fatigue or not? And then there's multiple boxes that have to do with manufacturing. Can it be manufactured at the right temperatures without too much shrinkage, without melting? Can it adhere well to these other materials that we use? So all that to say is, you can imagine the list of boxes that has to check, and EPP is the one that checks all of them the best so far. So it's like, hey, material engineering wise, this is the one. Now, how do we make it play better? Let's look at adding some flex into it.
Sure.
So that's where the holes and stuff come in.
All right, so we talked about the defects in the holes and how that applies to it. And now, of course, we've evolved to the classic is going to be that EPP foam, or a foam surrounded by foam, right? Sometimes now we got some with more than one surrounding foam, and some that's the triple layer foams, the treble foam from Chorus, or the F3 that's got three big layers of foam, which technically they have that fourth if they thermoform, right? So when we add those rings of foam, what is that doing for our paddles? What is that doing for its performance?
There's not a general answer here, because it's completely different depending on which foam you use, what density you use, what layout you use, when you're adding extra rings. Let me answer the most basic version first, just EPP center, EVA floating, and then we'll kind of go into detail on how you can go beyond that. The EPP center, whenever it goes all the way to the edge, imagine it's not floating, it's just one slab. It is, of course, more solid in the paddle as a unit, and it is now more adhered to the edges, so there's less movement allowed. This is going right back to what we were just talking about adding deflection, adding flex.
Right.
So when you kind of cut that in, and now you add a very soft, very elastic material like EVA around the outside, you allow that central core to have just a little bit more movement. And we're not talking about much here, but it's enough. Everyone likes to use like the trampoline analogy, like, it's a trampoline effect. In that case, the EPP is the tarp and the EVA is the springs running around, right? But you have to imagine it more like if your crazy carpenter uncle made a trampoline with a circle for a plywood in the center and it had springs all around the outside, and you were jumping on that. It still might give you some spring back, and it kind of moves as a unit, and the springs are doing something. That's more what it's like having the EPP center core and the EVA around the outside. Now, getting into multiple EPP cores like the F3, or adding additional edge foams, it's really going to completely depend on the densities of these foams and where you put them. To call out a few designs, and I'll talk about these because these are my designs, so I feel confident saying, why they were the way they were. The F3 specifically has a central core of higher density EPP, then a second ring of lower density EPP, and then an outer ring of EVA, right? And so it's kind of like a target. The purpose for that is that, the paddle naturally, based on physics, is going to give you the most energy return whenever you hit the center. As you go off center, you lose some energy return because now more energy is lost into twisting or whatever else.
Right.
Well, the F3 is trying to counteract that a little bit by now when you move out away from the center, you hit a lower density EPP, which has more energy return, more power, right? So you lose some power due to physics and you try to gain some back due to that foam core. It's trying to offset the power loss and make a larger sweet spot. The outer foam of EVA is the same concept we just talked about before. It's just a floating core. So that's that one. Upcoming Mavericks Havik 2, completely different concept. EPP floating core, a ring of EVA, so it's floating. And then on the bottom outside, kind of in a U shape or a horseshoe shape, is a third foam, which is a very high density foam that's not that elastic, and it travels around from one side, around through the throat, and around up the other side. And that's a totally different purpose. That's to add stability, to bring the balance closer to your hand, and to up the twist weight, while also kind of bringing that EVA closer to the center of the paddle in the bottom half. Because again, you naturally lose power if you hit the bottom of the face of the paddle.
Right.
This. So you kind of bring that EVA, that more reactive foam, closer to that to gain some of that power back. So it extends the sweet spot lower, adds a little bit more mass in the bottom, adds more twist weight. These are just 2 examples. There's a lot of examples. A lot of paddles out there are engineered differently with different purposes, but kind of you can do what you can do by using these different material properties in the right places.
Sure. So like when a lot of us paddle nerds add weight to the outside, right? We're increasing our twist weight, theoretically improving our sweet spot by building that. And it made a lot of sense then to put kind of dense foam on the outside, thicker, heavier. It adds that internal weighting, kind of like how some paddles will specifically put internal weighting. Call out Paddle Tech,
Yes.
putting fishing weights at 3 and 9 of their paddles. Ingenious, right?
Yeah.
But so why don't we just do that with foam in general? Put the EVA in the middle and the EPP out at the sides. What's the problem with that? Where the less dense and then the denser, thicker foams?
It will fail deflection. It will fail testing. It would break immediately. Like what I was saying earlier about the list of check boxes, the EPP checks, EVA does not check those. It doesn't have enough like compression fatigue resistance. It will disbond. It will be a rocket ship, all that. So you have to have a decently high density foam in the central hitting zone in order to pass testing for our organizations, right? Deflection testing and power testing. But I'm with you, and I think that we will see more companies with, yes, you have a correct hitting surface foam in the middle. Maybe you have EVA or another elastic foam. But then on the outside of that, why wouldn't you have a more dense foam or other more dense material to up the, frame rigidity and the sweet spot and the stability, which is kind of similar, actually. You can cut this, okay? I'll tell you this now, because I'm not trying to make a commercial for me, but I can only talk about these designs that I made. But the Valair Shift actually has, for the edge foam, all these paddles have this yellow expanding edge foam that we've all seen.
Right.
The Valair Shift, we actually used a much denser edge foam that still served the same manufacturing purpose, but it's a carbon-infused edge foam, so it adds a lot of stiffness to the frame in the paddle while also adding weight and mass around the outside to kind of bring up that stability and twist weight. So yes, you can do that, and yes, you probably would see more companies doing something like that. So you're onto something there.
Yeah, it makes a lot of sense. So now we've got the foam, we've got the rings. We talk about floating because these, the central foam and the rings of foam, they're not attached to each other, correct? They're not adherent for the most part, right? Why would a company choose to adhere them, and why would they choose not to adhere them?
Well, increasingly, people are choosing not to. In the beginning, I think the going understanding was, hey, let's make sure everything's adhered to everything because it'll be more solid, right? Well, there's a ton of movement, like we talked about, between the foams, and as they're shearing, it's really easy for that adhesive to shear between like the EVP and the EVA, for instance. And this is a lot of what we saw, we called break-in on a lot of these foam paddles, was actually just the adhesive shearing. And then now all of a sudden the central core, the EPP core, whatever it was, is allowed to move more. We saw the same thing with honeycomb, by the way, with Gen 3s.
Right.
But yeah, so now that that's known, most people think it's better to engineer these foams where they are not adhered to each other. They're still adhered to the faces on both sides, so they're not going anywhere. They're not moving at all. But why adhere them to each other if they're going to break apart anyway? It's going to make the paddle change over time. In fact, there's been a lot of experimentation with, if you're not going to adhere them, how much of a gap do you leave? A larger gap, a smaller gap? What is the difference in playability, and what do you gain there?
And if you look at some of the X-rays, some of the gaps are fairly significant, and some of them aren't. They're you can almost imperceptible, and other ones there's a fair amount of gap in there. And so
sometimes that's intentional, sometimes not. Most of the time, I would say that's not intentional, because a lot of these foams, if you don't use the right kind, like there's temperature resistant EVA, if you don't use it, if you just use regular EVA, it shrinks like crazy in the temperatures that it takes. Sure, you lay it in there and it's going to fill up the spot, and then as soon as you cook it, it just shrinks and shrivels, and then now there's a massive gap. I.e., look at the Franklin C45 X-ray. Oh, it's built like a Yola, but for some reason there's a giant gap between the EVA and the honeycomb. That's because that EVA is shrunk away. It didn't start that way.
I see.
So that's normally what's happening, but some of these companies, I think, are intentionally leaving small gaps on purpose.
Gotcha. So I think the general theory is that break-in, then we're kind of separating those rings, allowing that separation to exist, right? So Are you a proponent of forcing that separation with just gameplay or with other means? People have talked about bouncing, say, a denser ball or a massage gun, or even adding your heel to the corner of the paddle or anything like that.
I'm not a stomper, and I'll tell you why. I don't stomp my paddles because in the name of R&D, I've done it quite a bit. Not for my personal paddles, not for my mains, but I'm trying to like see what's going to happen. And I'm not joking, you guys, like over 50% of the paddles I've done this to have broken. So I don't think it's healthy. And I've done it side by side with the same paddle, right? 2 copies of the same paddle. And the most often occurrence is the one that is stomped ends up breaking. The other one ends up being fine without any durability issues. Now, and I've tried other break-in methods too, of course. I've tested all these. I don't do them on my main paddles, but this is for the R&D purposes, whether it's a lacrosse ball, a massage gun, the vise, and heat guns, freezers, combinations of all of these things. I would recommend none of them. And I actually think it's poor engineering. I mean, maybe that's too strong. I don't want to hate, but paddle companies should be more aware of how their paddle changes over time and try to engineer it in a way that it will hold up and be durable and play very close to its original state for as long as its life is, which we understand these are consumables. So the life of a paddle, if you're playing a lot and playing hard, I mean, honestly, 6 months is like you're getting a lot out of your paddle at that point.
Sure.
So that's just the reality. But let me just say this, though. Ever since Gen 2 paddles came about, there has always been, I don't want to call it break-in because I don't want to confuse it, but let's just call it like loosening up. Anyone who's played a lot of paddles knows this. And this can be true of anything. A brand new pair of shoes, a brand new car.
The same thing. Your shoes do the same thing. You're right. Your car.
Yeah, and your shoes do it a lot more. But if anyone's ever bought a brand new car off the lot, it's like actually a little bit tight and maybe kind of squeaky, and you hear some creaks for like the first maybe 2-3 weeks, and then it settles. Everything settles, right? And these are just all the things that are just minorly off, and then I'll go over a few bumps, and now they settle into their spot, or whatever it is, and it feels a little bit smoother, a little bit quieter, and then it stays that way for a long time as long as you keep it in good repair. That's how a paddle should be. And this loosening up phase has happened since Gen 2. It still happens with foam paddles today. It's just because the inherent qualities of epoxy, which is what is in the layup, it's in the edge foam, I mean, it's around the edge of the paddle, everywhere. It's very brittle, and it's going to make a ton of bonds to anything and everything that it touches that it's able to. And then as you kind of play with the paddle, these more tenuous, loose bonds are just going to kind of crack and break. And that's not a bad thing because the paddle's still holding together. It's still definitely glued, but it just kind of loosens up a little bit, loosens up the epoxy, and then it plays a little bit nicer. But that's okay. If a paddle loosens up over the first, let's call it week or two, and then stays the same, I'm happy with that. But it's going to keep changing.
Yeah, absolutely.
I'm out.
Gotcha. Yeah. That makes a lot of sense. Makes a lot of sense. All right, so I'm still stuck on the rings, right? And so we'll get off that in a second. But thickness.
Yeah.
Some rings are thicker.
Okay.
Some rings are thinner. Are all rings created equal? Is the thickness, is it okay to be thin, Justin, or do you really need to be thick?
Yeah, girth is super important for foam rings. Well, this is like it depends answer. This is kind of my thing I'm famous for, right? Like rambling for a long time and never answering the question.
You should run for Congress. Exactly.
I know, right? Am I politicking right now? Is this what it is? Is this what it feels like? But yeah, it depends on the density of the foam, right? Because you can imagine a thicker ring of a lower density foam might actually weigh the same as a thinner ring of a higher density foam.
Absolutely.
And these different foams, EVA, like we talk about EVA, but like it's one thing, but not all EVAs are made equal. Like you can make EVAs a lot of different ways. It's kind of an umbrella term. You can, and you know this from your shoes. Like a lot of shoes have EVA midsoles, and some feel squishy, some feel hard, some have like bounce, some die really quick. So it's the same in paddles. So it really depends, and I honestly haven't figured out a good way outside of experimentation and just like kind of knowing my past experiences. Oh, we're using this density of this type of foam. The ideal ring width is X, right? And to me, it's a little bit different for each type of foam. So with, let's just say, I'll give you an example. Your general EVA that's in a lot of paddles, they measure it usually in hardness, but the density is around like 50 kilograms per cubic meter, 50, 55-ish. Once you get over 18 mils thick, 18 and over, it starts to really like hurt the stability, and the paddle can feel a little bit empty and, you know, kind of floppy, not in a good way. If you go to, let's call it like 6 millimeters and under, it might as well not be there. You like barely feel it. So the sweet spot is somewhere between like 8 and 15 millimeters for the width of that ring. And I'm a big proponent, and you'll see this in some of my designs too, of variable widths. I think that different widths of the edge foam actually make bigger impacts at different parts of the paddle.
Sure.
So we'll see who steals this idea, because I haven't seen anyone doing this but me. But I personally like a thinner EVA ring at the top, because I don't want a dead spot at the tip of the paddle, because you use that often.
I'll call out the paddle. It's the run out, right?
Well, I've done it on multiple paddles. This is like maybe this has become a little trademark of mine, variable width edge foams.
There you go.
But yeah, so thinner at the top personally gets rid of the tip edge, a dead spot, which is a complaint on a lot of paddles. And you can afford to go a lot thicker with the EVA in the throat, because you're not really hitting the ball down there, hopefully, near that edge. So you're okay with bringing the EVA much further in. It gives a much more dampened and plush feel overall, because it's so near your hand.
Right.
So anyway, there's a little nugget, little R&D nugget.
I like it. All right, so you touched on EVA foam, and I wanted to touch base on the foams, because right now that's kind of the big thing right now. EPP, MPP, super critical. Shout out 60 Aerospace. We don't know what exactly
I don't know what that
is. It's from outer
G4
space.
foam,
man.
they call it, I think.
It's for outer space. So you already mentioned that EVA foam is not EVA foam, right? There's multiple variations of EVA foam, correct?
Yeah.
And
you can build it differently.
Yeah.
Yeah.
And EPP is the same, right? There's, I think, what is it? The Tornazo advertise themselves as using PIBA. I forget what PIBA stands for, but it's a
polyethylene block amide.
There you go.
It
was on the tip of my tongue, Justin. It was right on the tip of my tongue.
I might be wrong, but I think that's what it is.
But because you see this a lot in running shoes, right? And so they'll use different densities of EPP for performance and cost and all that kind of stuff. MPP, the microcellar, I assume that's the same. Not all MPP's the same, or is that more alike than others?
So a couple things here. PEBA, or the brand name, is Pebax. It's like a name brand of PEBA. That's not EPP, by the way. That's something totally different. It's its own foam. Yeah.
Okay.
EPP, expanded polypropylene, is like telling you the polypropylene that then they bead and expand. MPP, microcellular polypropylene, same plastic, same polymer, different foaming process.
Okay.
So EPP and MPP are actually much more alike than either of them is to PEBA. So anyway, but yeah, you see Pebax, the brand name of it, in a lot of running shoes right now, because it's essentially come out as a better version of EVA. It's lighter, but has more energy return and less compression set fatigue, so it can bounce back to its shape better. So in marathon running shoes, that makes a lot of sense, right? You want a little bit more energy return, you want less weight.
Right.
And when it comes to EPP, all of them are made equal or not. They actually are, I would say, yes, more equal than not, because it's pretty narrow what that polymer is. But you can obviously get it in different densities. And within those different densities, and sometimes if you're on the borderline between a certain density and another one, you can use different size beads. And they actually expand to different rates, right? Like, so these are made up numbers, but let's just say you wanted to make like an 80 kilogram EPP. You could use the smaller beads and let them expand more to get to that 80 kilograms, or you could load in the bigger beads and they would expand less. And that's just going to basically change the cell structure in the final form, which does change a lot of the material properties about how it feels and things like that. MPP, same kind of situation, a little bit different process.
Gotcha. Should we expect to see other type of foam types coming in the future?
Of course, why not? Yeah, I mean, foam. When people say foam, they're like, oh, it's a foam paddle. It's a foam paddle. But I've said this before, but that's such a giant umbrella term. It's like saying metal. Like, bronze, tin,
Sure.
Gold, aluminum, steel. They're all so different, and some of these are even alloys, right? They like combine multiple things, and they all have different use cases and very different material properties. So same can be said for foam. When you say foam, there's so many different polymers you can make foam of, and you can even make alloys, if you want to call them that, and make custom foams, which we haven't gotten to in pickleball because honestly, the money and the demand's not there. But in running shoes and other industries, they are definitely making custom foams. Like you see Nike React, or these different brand name foams. The reason why they're brand name and trademark is because they're like a custom formulation of a type of foam.
Gotcha. Is it still
there's a lot more
plastic, for lack of a better word, a plastic type of bead base, basically? And we all know there's tons of different plastics, right? So
yeah. So polymer is a better word, but yeah, it's
okay.
Kind of like that. And no, not all of them are beaded. That's one type of foam underneath the umbrella. Now you got your categories. You like your beaded foam that are beads that expand. You have blown foam, which is like, imagine like a molten melted plastic, and then they're like blowing a chemical foaming agent into it, and it expands out, and they come out in like blocks or sheets. You mentioned supercritical foam. Mm-hmm. Supercritical is another umbrella term. All that is describing is the process used to make the foam. Right. It just means that instead of using a chemical foaming agent, they use nitrous or CO2, these things that are actually more friendly for the environment. So supercritical foam usually is a little bit less dense, but it's also more environmentally friendly to create. So there are multiple different foaming methods, and there are multiple different starting polymers you could use. It's crazy. Honestly, it's way over my head. It's very deep, and I'm just a pretensioneer. I'm not an engineer.
So it sounds like we're limitless there. Good. Okay.
Yeah.
Let's transition over into face sheets. We talked a little bit about it, and I picked up on one thing you mentioned when they're laying. Let's say we have 3 layers of carbon or 2 layers of carbon face sheets. How they can be arranged. Carbon layer this way and this way, kind of 90-degree angles. That adds some stability and stiffness to that sheet layer, right? The C45, right? So that was one thing they were kind of famously promoting, that they were laying theirs at 45-degree angles to create more of a pocketing feel or a plusher feel, would you say?
Just funny.
So what's your comments on that and how you lay them down? And I say this because one thing, for those of us that have looked at our paddle faces with a microscope, it looks like a little weaved piece of cloth. So I don't know. So how is that,
I will demystify this for you.
Thank you.
Because first, let me tell you, what you see on the microscope is not the carbon fiber direction. I'll tell you that in a second. Okay. So let me answer this, and then I'll tell you what you see. So the orientation, like for the sake of this conversation, we'll just say if it's running straight up and down, we call that 0. We'll call this 90. We'll call these 45s.
Perfect.
Just for the sake of the conversation. So carbon fiber has like really strong tensile strength, meaning if the fiber is running up and down and you try to tear it this way, it's not going to stretch. It's also not going to tear. But you can imagine if it's just like a stack like this, you'd be able to separate it very easily, right? So now when you layer this one over top and you adhere them, now it's very strong in this direction, but it's also very strong in this direction. So these two it's like a symbiotic relationship, right? So they're helping each other. When you add additional complex angles, so not just 0 and 90, but now 45s into the equation, you are upping the stiffness, not lowering it. So a paddle like the C45, it's like, we want it to be more plush and more pocketing. That may have been the marketing, but that's actually opposite of what the testing would show. A paddle with 45-degree angles or, like more acute angles going on will actually be stiffer when you come to like a deflection test. So there may have been other factors, because every paddle is a sum of its parts. There may be other factors in the C45 that made it feel, but it was certainly not a soft paddle by any means. And in fact, when engineering and exactly. When engineering and you're failing deflection or you're pushing up against that limit and you're trying to get out, it's like, one way I know we can add some 45-degree layers in it to stiffen it up. It doesn't make it softer. Okay, so that's that. And you can experiment with different ways to lay this up. Just understand that the more angles you add in, the stiffer it's going to be. The more close to the same angle they are, the more flex you'll have in one direction, right? Like if I did like this, let's say, this is going to flex a lot like a taco, like this way, very easily. But it will not flex barely at all this way, because you have double reinforcement that way. And that's a paddle we probably know. So I just got to drop these little nuggets in there for anyone, the Easter eggs. Okay, so what you're seeing on the microscope
Yes.
is the impression of the peel ply cloth. So
Gotcha.
you want me to ramble on peel ply real quick and explain what it is?
Yeah. Oh, I was going to dig into that, so let's go.
Okay. So people call it peel ply texture. Peel ply is actually, it's a fabric, and it is a fabric that doesn't stick to epoxy, which we know all these carbon fiber cloths and everything are impregnated with epoxy.
Right.
So when you go to put all these parts that are wet and soaked with epoxy, right, into a steel mold, and you're going to heat it, and the epoxy is going to cure and stick. What you don't want is your paddle to stick to the steel mold.
Right.
That would be horrible. So, and this is not a pickleball specific thing, but they will put a peel ply cloth on top of the carbon fiber. And then that is essentially a buffer between your epoxy soaked carbon fiber and the steel mold. So then it is a woven cloth. That's what you see whenever you see on the microscope. So now when the paddle's done, they pull it out and they're like, okay, we're ready to print graphics. The peel ply just goes, peels right off. It's a ply that peels right off. It's just a fabric. And so now that that's taken off, what happened is it left the embossed imprint of its texture into the epoxy. This is a weird analogy I just thought of, but imagine if you had a carpet in your house that was soaking wet, and then you stepped on it with your boot and then stepped off. You could look back and see the exact texture of your boot print. Right. So it's the same way. The carbon fiber is so incredibly soaked with this epoxy that it squeezes out and then leaves the impression of the cloth when it's pulled off. And that's the texture that we use to generate spin. So that's what peel ply is.
Excellent. I like that. All right. So fiberglass. So about fiberglass. Now, if you buy an Amazon paddle, it's, or one of those, a lot of them, or it's that smooth fiberglass surface. Notably, there's been a few paddles, right, that come across, performance paddles that actually puts fiberglass on the surface. Mm-hmm. But most of the time we see fiberglass in the middle, that classic CFC layup, or sometimes they'll put the fiberglass up against the core first. So fiberglass. Walk me through a sheet of fiberglass. We've heard about fiberglass weaves. What's the difference? Mm-hmm. How do they make it? How does this lay down?
So fiberglass is just a composite, exactly like carbon fiber. Everything that we said up to this point about carbon fiber, we could also apply to fiberglass. Okay. So it's a different material, but it comes in the same medium, so to say. So that's why it can be added right into the same type of layups with carbon fiber, whether CFC, because it's also impregnated with the same epoxy. Just like carbon fiber, it can be unidirectional, meaning all the fibers run in one direction, or it can be woven. And that's what we've seen used in paddles. And when you think of these like lower performance paddles that are fiberglass paddles and they're smooth, they didn't come out smooth, by the way. They came out with a peel ply on them, the texture, and then they are then polished so that then they can be printed on and spray texture. Oh. It's just funny, right? Yeah. So yeah, like peel ply is just something that's used in a lot of composite industries, just like I said, so it doesn't stick to the mold. And so you can work multiple stacks of things at a time without them sticking to each other. But yeah, so the smooth ones are usually taken out, cleaned up, sanded down, polished, printed, spray grit.
Okay.
Yeah.
Interesting.
But use case in the performance paddles, it's exactly the same process and everything as if you used another layer of carbon fiber. You just grab a layer of fiberglass instead, put it in a layup. Like I said, unidirectional or woven, and there's different weights that you can use, so different thicknesses and amounts of fiberglass. Why don't people use it on the top surface? Well, fiberglass has very specific, harsh frequency resonance, so vibrations that can feel really bad. We've all felt really harsh fiberglass paddles, and the more you kind of bury it, so to say, the less you feel it in your hand. So that's why it's better to use maybe in the middle or the bottom. And why use it over carbon fiber at all? Two reasons. Number one, it adds, it's more flexible than carbon fiber. Actually, people think of it as more stiff, but that's just because it feels harsher. It's actually more flexy. So it adds bounce or pop a lot of times to paddles. And then here's a hot take. Okay. Here's why I think people like it. Some people. I've been talking about this recently with some, like, a couple close friends, but I haven't actually revealed this yet. I think that people tend to like fiberglass because of that same resonant frequency I was saying.
Yeah.
It actually masks a lot on your paddle. So a lot of these CFC paddles, they just feel the same no matter where you hit the ball. Oh, you mishit, you hit the top, you hit the bottom, you hit the side, you hit because the fiberglass resonance frequency is so strong, you feel it in your hand. So it's almost like every hit feels so similar. And I think that gets conflated with, oh, this has a huge sweet spot because it feels the same everywhere. But I don't think the sweet spot's actually bigger. I think it just feels the same. This is my hot take, all right?
All right, you heard it here first.
And this is why I'm not a fan of fiberglass. I don't like the vibration feel, and I also like to feel where the ball's hitting. I want to know what the paddle's doing. I want to know what the ball's doing. If I miss hit, okay, I need to know because I need that proprioceptive feedback personally.
Gotcha. If I suck at
so that's
pickleball,
my hot
I
take
want to
theory.
know that I suck at pickleball, all right?
Yeah, true. But I think that's actually a big rise of the popularity of fiberglass, especially with like lower level groups. It can instill confidence every time you hit the ball, it feels pretty similar. You're like, dang, this paddle's a huge sweet spot. Everything feels the same and it feels consistent in a way. But
that makes sense.
Anyway, another tangent.
The last face layer that we commonly see, or maybe not as common right now, but we do see is Aramid, right? So Aramid fiber.
Right.
Oh, actually, I got two more, right? So Aramid fiber.
Okay.
Walk me through Aramid. Kevlar is a brand of that, right? So walk me through that.
Yeah.
Why people use that? Why some people will think it has a little bit of a softer feel, maybe. What do you think?
So Aramid and then Kevlar is a branded. The same thing, by the way, as like Peva and Pebax. It's a branded version of Aramid. Again, I think it's the same reason as fiberglass. It's a low-hanging fruit because you can use the exact same method. It's just plug and play.
Right.
Take out a fiberglass or take out a carbon fiber layer, put an Aramid layer in there. It's normally woven because it doesn't have the same type of strength when it's unidirectional. So that's why you see Aramids as wovens. It's just the material properties are going to work better in a woven, application. So it is actually stiffer than the others, even though people say it's softer. Here's why, though. Because it's woven, whether you're talking about fiberglass, carbon fiber, Aramid, anything, when you look at a weave versus like a 0-90 layup of unidirectional, you are adding both a little bit more flex and more vibration dampening because there essentially are tiny little air gaps, right? Every little place that this weave is overlapping. So that's places where vibrations can die. So that can feel softer to our hands. So that's why a lot of these Kevlars or Kevlar carbon or other Aramids can sometimes have a unique specific feel. I mean, I think it's a perfectly fine material to use. It has a kind of specific feel. I don't really think it changes performance too much, but it changes aesthetics quite a bit, which is cool. If that's what you're going after, why not? In a sea of paddles that look the same, make something that looks a little different and accepts dyes and colors in a way that carbon fiber doesn't.
Makes sense. And then, titanium, PET. You're familiar with that, right?
Yeah. So that's just carbon fiber. It's just a carbon fiber weave. And then they also weave in these little strips of electroplated polyester, PET. And the original version of this was kind of a silvery gold color. And when you went to the supplier, the color of the material was titanium. It was 3K carbon weave with titanium polyester. The titanium was the descriptor of the color, and that's where this whole mess came from.
You had to put on your Sherlock Holmes hat and your microscope, and you broke open the news.
I feel like I was more like a MythBusters than Sherlock Holmes. But this. For those who didn't see that, this was probably over a year ago now on the podcast. I had to come on the podcast and say, hey, it's not titanium.
It's not real titanium.
I was kind of nervous about doing that. I called all these suppliers, both in the US and in Asia, and I was like, you're sure? Can you send me the material spec sheet? Because I can't say this if I'm wrong.
That's right.
Because all the paddles at that time were advertising titanium. Then I said it, and then everyone still blew up and were like, you're wrong. So then it was 3 weeks of clarifying, but that was fun. Anyway, for those of you who are at the titanium days, leave a comment because just let us know you lived through that.
That's right. That's right.
But
you don't see it so much anymore.
It is.
Is it more expensive?
No.
Is it changed?
Yes. Yeah, it is a little bit more expensive. I don't know why you don't see it because, well, it's harder to QC because the electroplated color can like kind of chip and fall off. So you have like
Sure.
these imperfections. And it's very obvious when it's like a shiny material and then all of a sudden you have spots that aren't shiny, which we've seen.
Right.
So that can be a pain. Maybe people don't want to deal with that. But the material as a whole is actually just like a 3K carbon weave. But just like we talked about with the Aramid, this is actually like a perfect little segue because the same thing is happening. When you have a woven carbon, it's a little bit softer, it's a little bit more flexy, a little bit more dampening. This is versus unidirectional carbon. And then you add a softer polymer material like polyester woven through there. You're creating like another tiny buffer in this weave that makes it even softer and even more dampening. So that's why
Right.
these titanium paddles have felt like buttery and like a lot of times really dampened, sometimes over dampened. But yeah, I actually think the feel of titanium and the performance was pretty good. I just can understand from a manufacturing perspective, it's not the easiest to use because, like I said, it can be annoying to QC and it's a little bit more expensive and harder to source.
Gotcha. Gotcha. So the peel ply goes on top of all these different surfaces, whether it's carbon, aramid, fiberglass, PET, all that kind of stuff. And then you peel it off, and you've got your grit, right? So let's kind of go in there. So the grittiness of any of these surfaces really should be the same because it's the grittiness is coming from the peel ply on top, or should any of
Yes.
those different surfaces impart different type of grittiness, spin, etc.?
When you talk about grit only, um, if they use the same peel ply, the same grit, but remember that it's just the peel ply is just embossing the texture. So there are
Right.
multiple different peel plies that are either more tightly or more loosely woven. So you've seen this. You've seen fine grit and then
Right.
like the coarse grit. That's just a peel ply cloth is either a larger weave or a tighter weave. So the texture it embosses is either tighter or looser. So yeah, the grit the same. Now, spin, of course, we know is a combination of kind of grit or grab and how long the ball's on the face and how
Right.
much of the ball's on the face, which has to do with the face deformation, deflection, and the ball deformation. So you can affect different spin with different materials. We've already talked about a couple times how these woven materials tend to be a little bit softer, a little bit more deflection. Well, that can lead to a larger surface area when the ball contacts the face. And that little bit larger surface area, even if the same amount of grit, can impart more spin. That's why in a vacuum, a lot of times these titanium paddles with the same grit were imparting a little bit more spin than their unidirectional cousins,
Exactly.
so to say.
It kind of feels different.
So yeah. Yeah.
Gotcha, gotcha. So, what do you think about the innovations now that are coming around grit? Right, we've seen Boomstick or Selkirk's. We'll say this because it was on their which was it? The
007?
Yes, and they're Infinigrit, right? In the that we've seen from them, we've seen 6-0, their Diamond Grit, Spartus's Permagrit. And then Hex Grit coming out from 11.6 and Harmony Grit that's going to be coming out from Chorus. Looks like that seems to be another new wave that we're starting to see. What are they doing to try to make that grit last longer?
Okay, I can't reveal secrets, but
Sure.
we talk about the ones that we know and just in general terms.
Sure.
Like we know that Selkirk's is a spray-on.
Right.
I mean, you can see that under the microscope, right? So, and you can tell because they have full color graphics, and they're the only company that has a long-lasting grit that has been able to do this. So that's actually really cool because Selkirk paddles, they're unique looking. You can tell they got a giant S on them, right in the sweet spot or whatever. Other paddle companies aren't able to do this because when you print over the texture, and you will lose a lot of spin. So props to Selkirk for that. And yeah, it seems like all their claims are being backed up by all the independent testing. They said lasts about three times longer than peel ply, raw carbon fiber, if you want to call it that. And that's rang true. There's like a little bit of a drop off, and then it lasts, and then where peel ply keeps dropping, it keeps going, and then it eventually drops. But so that's really good. Props to them. The 6-0 Diamond Tough is the patent is out. This is public, so I'm not revealing anything, but they are using little pieces of industrial diamond, so in the grit, and they're mixing that into the epoxy resin, which is then impregnated into the carbon fiber. So same process, and then there's a peel ply cloth on top. Everything is exactly the same. Just imagine now the epoxy holding your carbon fiber together has little tiny sharp pieces of diamond in it, and they're way harder than the ball. So where the ball might chip off epoxy and smooth it out, it's not chipping off the diamond.
Not chipping off the diamond, sure.
Yeah, so that embedded diamond's in there.
I think they describe it as if the piece of the diamond falls out, the next one mans up to fill in the gaps.
Yeah.
But I guess they're saying that
right?
there's diamonds that just evolve in all the depth of the epoxy that's left. Yeah.
Yeah, because it's completely like blended in and embedded in the epoxy, right? So even if you were to like lose some off the top, it would be like digging in really rocky ground, right? Like you're like, oh, I got these rocks out of the way, and then as soon as you put the shovel in, you're like, oh, another rock, and even if you're picking them off the top, there's always more like rocks underneath, and so that's probably the diamonds in their epoxy resin. I haven't seen any studies on it, but I imagine based on the engineering, that's going to last a really long time and do really well.
Sure.
Spartus, completely different process again. Ceramic hybrids. That's all I'll say about that. Hex grit seems like it's going to last a long time. Works really well. I've been playing with that paddle. Yeah, we'll see if we hear more details about what that is. But
Josh from Spartus has, he's released a video. He's talked about it. He's talked about his grit, that it's ceramic. What would that mean? I mean, obviously, we don't know exactly what he's doing, but what would ceramic... We think of ceramics, we think of a pot, right? And so what does that mean as it applies to a surface? Is it a literal ceramic material that's embedded in that epoxy, or is it a totally different process?
I think it's different. But let's just say about ceramics, like there's something called the Mohs hardness scale.
Right.
And basically different materials grade softer or harder. And it's very basic. Like a softer material can never scratch a harder one, period. And a harder material can always scratch a softer one. Like if anybody watched Jerry Rig Everything, when he tests his cell phones, it's a glass top. He's got the little Mohs hardness things, and he's scratching different numbers going up the Mohs hardness scale. And you'll see where the glass starts to scratch, and okay, that's where this glass fits on the hardness scale. All that said, a pickleball is plastic, and anything else you might hit, maybe even tiny rocks it picks up, which is very rare, but all those are going to be pretty low on the Mohs hardness scale, whereas diamond and ceramic are going to be extremely high. Sure. So the ball is never going to scratch ceramic. The ceramic will always win in that exchange. Same with the diamond, and I'm sure same with all the other grit materials that are being used for long-lasting grit.
Interesting. I think it seems pretty cool. He also talked in his video when he released it about not only addressing the grit friction, but the coefficient of friction, right? So the stickiness of it. And if you felt a P1, which I know that you have, and many of our viewers here, especially if they're this deep into the video, they've probably seen a P1 or hit one. It does feel sticky. How would you accomplish that sticky type of feeling? AKA, what was it? One of the protons had that as well, kind of, right? Yeah.
I think that one got quietly, get out of here, Because there's specific rules about using different rubberized coatings and things like that, which I don't, Spartus isn't doing. Actually, I don't have a P1. I ordered one.
Okay, gotcha.
Let me, a little personal note here. P1 is the first paddle that I've personally ordered and paid for in probably over a year, which I know is a crazy brag, by the way. I wasn't trying to just casually brag. I'm just saying it's that interesting.
All sorts of nuggets of info here from Justin today.
Yeah. I still don't have it, so I've actually never played with it or felt it. I look forward to it.
Gotcha.
But
it feels pretty cool. It is different. It feels cool.
Yeah, that's what I've heard. So yeah, I think that's really smart to approach the coefficient of friction angle as well as the grit angle, because like we talked about earlier in the spin, all these factors really just combine to friction. And whether that's grit, the amount of deformation in the ball, the amount of deformation in the face, all this different stuff. So if you can have more friction whenever the ball and the face interact, you can impart more spin, period. So yeah, it's very smart of them. Good engineering. I don't know how they do it. And if I did, I probably couldn't say.
Perfect, perfect. All right. I'm going to hit you with some quick hitters here. All right. Just give me some quick fire answers.
Good luck.
That's right. Exactly.
Good luck
Core
keeping me
thickness.
quick. I mean,
Core thickness preference 16, 14, 12, 10. What do you like?
no answer. Completely depends on the paddle.
Oh my gosh. He keeps the politician. The politician comes out,
No,
guys.
but seriously, I think that okay, fine. This is my last rant. I think core thickness is overrated, and it cracks me up how many people are like, "Oh, I don't like this because it's X thickness," or "I only like 16s."
I
When
only
in
play
reality,
16s.
if you pull out your calipers and measure paddles, tell me how many are marketed
Right.
as 16, which are actually 15.4, 15.8, 16.5. They're marketed as 14s, they're 14.8. They're almost a 15. Like,
Yep.
this is a lot of it is marketing. Just play the paddle. It's paddle is the sum of its parts.
All right, technical difficulties. We are back. All right, so we got a, politician answer from Justin about core thickness. But I will tell you, Justin, one thing that I've started, X-raying and then having access to a CT scanner, CT scanning these paddles, and I completely agree. Those thicknesses, when you actually measure it, I measure with the CT scanner. Yeah, they're not all right where they say they are. They're close, but they may not be exactly where they say they are.
Yeah.
All right, internal weighting. Is this just to cover up a poorly made paddle, or is this an important thing that paddle makers should do?
Smart engineering. Why not?
Perfect.
I like it.
Excellent, excellent. Do you like the fishing weights? Or do you think
it's crude. Hey, and they changed from fishing weights to ball bearings, so they made an upgrade. It was a bit crude because sometimes they would shake around, but I applaud the effort. I think it was, like I said, sometimes engineering solutions don't have to be super complicated.
Absolutely, absolutely. Now, when you advise companies to put some internal weighting, do you look at more carbon, fiberglass, or a metal? What do you prefer?
These days, a lot of times fiberglass is the easiest. You can get it pretty thick and enough weight, because when you're internal weighting, it's not like you're adding more than maybe 3 grams max in one spot. It's really going to be more like 1 to 2.5. And when it comes to metal, you don't put it inside. You usually have to put it under the edge guard, and that can sometimes cause, edge guard coming loose. So if you're going to put it inside the paddle, which is probably best, usually a thick fiberglass is the way to go.
Gotcha. Speaking of edge guards, most edge guards that we see just seem to be just a simple plastic. One company that you've worked with, Forge and Bond, have done pretty unique, their edge guard, right? That, I forget, what was the term they called it?
Fusion fiber.
Yeah, fusion fiber. Do you see innovations going in edge guards?
I hope so. I think that they should. That's what we call like a blue ocean, right? Right now, all edge guards are TPU, which actually works pretty well. It's easy to make. It's affordable. It's vibration dampening, all that. But I hope that we see some innovation there.
Okay. Recently, neck flex has kind of become a topic that the pickleball nerds have talked about. Is good, bad, how that applies to anything from power to feel. What's your opinion on it?
Yeah. Beam flex is probably the other term, It's neither good nor bad. It just creates different feels that people are going to have different preferences towards. I actually prefer a paddle that doesn't flex that much at the neck. I'm of the opinion that the paddles that play and feel the best are the ones that kind of replicate what we know to work from like tennis rackets, right? Like, so a stiff frame, but a flexible face.
Right.
Yeah, I tend to think that too much flex at the neck can make your paddle feel like a dead fish.
And that was one of our differences between the traditional Gen 1 to Gen 2s, right? That added that little bit of thickness, and that brought that up. Cool. All right.
Yeah.
You wouldn't happen to be a handle snob or anything like that, would you?
Oh, yeah, famously.
Gotcha. So I think we know you like stiffer handles than versus the soft foam inserts. You like the PU inserts.
Yes.
I think you've shared on the podcast that you will 3D print your own quite often. for a paddle. But when I've X-rayed and CT'd paddle handles, they're pretty simple creatures, you know? It's not much to it. But the one company, 60, right? They've done a lot of innovations. They threw little silicone tubes looking in there and called it vibration dampening. What other handle things do you think may be a place for paddle makers to improve the feel of these paddles for our players?
I mean, fully molded. You mentioned the F&B, the run-out paddle. It's a fully molded forged carbon fiber handle. To me, that is like one of the best feeling handles on the market.
It's a great handle.
And it's more than, it's more than just feel, but when you fully mold a handle, it's really not that hard to do in the process because you're already molding the paddle. You just build it into the mold the handle too. But you actually help yourself in a lot of ways because you can mold the butt cap right into it. And something that happens pretty often, you've probably seen this because you've had a lot of paddles, is butt caps get stapled on a little bit crooked.
Yep.
So now your paddle feels kind of weird to hold in one way, and then it feels, okay, I need to hold it this way only because the butt cap angle is a little bit off.
Right.
Not to mention that, but when, reviewers are measuring swing weight in the machine, it's going to measure differently on one side than the other if the butt cap is crooked. So if you can mold all this in, you actually take out all of that human error in assembly, whether it's stapling on or gluing on the pallet, stapling on the butt cap, and then you can clearly define the exact shape and dimensions right from the get-go, and you can make sure your bevels are sharp, the exact circumference that you want. I just think it's better.
Gotcha.
We'll see. I'll see how many people I can convince to mold handles if you see some more molded handles in the market.
Now, do you like the square handles or the more oval ones?
No. Well, I wouldn't say oval, but if you're looking at a paddle like this, I prefer a handle that is more rectangular, so wider than it is tall.
Yep.
Because that's like a Wilson tennis racket. That's like, you can feel the shape a little bit easier when it's more rectangular. When they're the same width as they are tall and they're square, it just feels blocky, and like every way you hold it feels the same.
I'm the same way. I don't have the hugest hand, but like some of Selkirk's handles, little blocky for me. I do like the more rectangular ones. I'm with you on that one.
Yes.
Well, Justin, I feel like I can go out and build a perfect paddle now. I don't think your job's this hard, man.
Okay, all right. Well, I just lost a client.
Good deal.
Or I just gained a competitor. Are you gonna become a paddle consultant?
No, I think I'm gonna stick to delivering babies and reviewing paddles on the side. How's that?
That seems way harder, honestly. My job is way easier.
Man. You just got to stop him from hitting the ground, man. It's easy. So, all right. Well, Justin, thank you for taking the time and appeasing the pickleball nerds and all of us and paddle nerds about all the details about construction and stuff. I really appreciate you taking the time out of your busy schedule to talk with us today.
Yeah. Hey, thank you. Last question real quick. I'll ask you now.
Yeah.
I said at the top that I was just going to ramble and not prepare at all, and that you had all your notes. Did I get you off your notes? Did I mess you up? Did I trip you up?
No, buddy.
Did
no, man. I'm a
we stayed on track?
I'm a professional, man.
That's pretty good. That's pretty good.
Last
all
question
right, man.
for
Hey,
you.
thanks for having me on. Yeah, go ahead.
What is your favorite whiskey?
I don't drink. So... I'll tell you one though.
We found a flaw in Justin. We found a flaw. There you go.
I don't drink anymore for medical reasons. So it's fair enough. But I used to pretty regularly drink whiskey and sometimes whiskey and Coke. And let me actually see if you know this one. It's called Collingwood. It's a Canadian whiskey. Do you know it?
I don't know that one. How did you find one whiskey out of the thousands of whiskeys that I know that you got past me? All right.
It's probably not that nice. But it's a blended Canadian whiskey.
Yeah.
And it's just incredibly smooth. And it's like, to me, it's like the grown-up's Crown. Everybody likes Crown, but it's just like a much more refined Crown. So I'll have to text you the name of it. You'll have to look it up, and then you tell me, hey, this sucks, or hey, it's actually pretty decent.
I'll tell you if it's as good as a molded handle. All right. Perfect. Where can people find you? Obviously, they know the PP podcast, right? Pickleball Pursuit podcast. Justin's a co-host. Yeah. Everybody follows. Everybody subscribes to him, so you see him there.
What else?
What other stuff are you doing?
That's it. I mean, Pickleball Pursuit podcast. I'm on that. That's the only real social I do because my job isn't out front. I don't really need to market
Sure.
myself. I'm kind of working behind the scenes. I mean, yeah, I have Instagram. It's Pickleball, etc., Pickleball etc. But I don't do anything exciting. Only thing I've actually posted 0 times. My only posts on there are whenever companies or people or whatever I've collaborated with, like they post something, ask me to collaborate, I'll collaborate. And then I'll post a story from time to time or collaborate with people. But yeah, there's no reason to go follow that.
Sure.
Unless you just like really want the nerdy stuff here and there. But
Gotcha.
yeah, just the podcast.
All right, man. Tournaments coming up. You been playing?
Yeah. PPA. You'll be there. Dallas.
I'll
PPA
be
Texas
there.
Open.
I'll be there. I'll be
Yeah,
in
so
the
playing
old man
4-5.
I'll be in the old man division 3-5.
Yeah,
Justin's
senior
got-
pro, right?
You're
playing
right,
senior pro?
senior pro. I've seen those senior pros. Man, they are good. They are
Very
really
good.
Yeah.
Yeah.
I'm over in the clunker division, but I have a lot of
I'm playing the young
so-
boys division this time because
my
my
God.
partner's young. So the whatever 8 to 34 or whatever it is, 4-5. So we'll see how that goes.
Dude, don't lob them, man. Don't let they just jump out of their shoes and crush it. So,
Yeah.
all right, good.
All right, Martin.
Well, you take care, Justin.
All right.
Peace.
Thanks.